Okay, so we now start with the second question of ICSE Specimen Paper 2026. So the question number 2 says that this diagram shows the electroplating of steel object. This object is made up of steel, right? And it is to be plated with silver. So there are the three steps. So the first step, it says, is coating of copper, right, is applied to the object, then coating of nickel is applied to the object, and finally there is coating of silver to be applied, right. Now in step 1, it says a diagram of apparatus used in step 1 is shown. Now the chemical process taking place on the surface of the object is this. Okay, what is the observation seen? Now look here, what is happening? There is copper and solid, so that means there is deposition of copper on the object. Now what is the color of copper? It is reddish brown, so there will be deposition of reddish brown coating of metal copper. Then says, next part is explain why the concentration of copper ions in the electrolyte remains the same throughout. Now what is happening? Over here anode has got copper. Now anode, because of the higher potential, it is going to higher reduction potential, it is going to release 2 electrons. Okay, now these are ions, so they will come into the solution. Okay, so what will happen? This anode made up of copper. Now this copper has come over here, so this will become thin after some time, because gradually copper is changing into copper ion. Now these copper ions, they will accept 2 electrons and will get deposited in form of copper solid metal. So there will be deposition of copper here. Okay, so therefore say suppose 10 copper ions are being formed, 10 are getting deposited. So therefore the concentration of copper ions in the electrolyte will remain same, because 10 are entering and 10 are going. Is this clear? Then next it says give 2 changes that would be needed in order to coat nickel onto the object in the step 2. So in first step, that is copper. The second step, it has got nickel. Now what we have to do is, there is already deposition of copper. Okay, so now it has to be coated with nickel. Now in order to get coated with nickel, first we have to remove the electrolyte. So here electrolyte is copper sulfate, so we are going to replace this with the electrolyte containing nickel ions, right. So this is the first thing. Second thing is, what will happen? There will be deposition of copper metal on the cathode, right. So that amount has to be, right. So it says the next change what we have to do is that we have to replace the copper here. Now look here, here there is the metal, so here you are getting deposited the nickel. Okay, now this nickel electrolyte you have changed, right. Now from where this nickel is going to come? So this copper electrode is now to be replaced with nickel electrode. So what we need? The electrode should be of nickel. The ions present in the electrolyte should be nickel ions. Then only nickel deposition will take place. Okay, so this is the answer, right. Then we talk about the third part. What is the reaction that is taking place at the positive electrode, right, in the step 3. Now step 3, what is happening? Step 3, there is deposition of silver. Now you have got 2 electrodes. The first one is anode and it is positively charged. So what is happening? From anode what will happen? There will be loss of electron. Okay, so oxidation occurs over here. So this silver is going to break into silver ions and electron, right. Here you will write silver in solid, here you will write silver in aqueous state. Okay, so this is the reaction, right? Now next we come to the second part. Here you have to identify. So these are the definitions given. You have to read and understand and then identify. They are talking about which, okay, which of the following things. So first, a bond formed between two atoms by sharing a pair of electrons, and both are provided by the same. So always remember, when it is equal sharing, then it is covalent. When it is from one side, then it is always a coordinate bond. Okay, so that means this is, we are talking about coordinate bond. Next, a salt formed by complete neutralization. Now, when there is neutralization, it can be complete, it can be partial. So when we talk about complete, then it is always a normal salt. Okay, let's take example. Example can be sodium chloride, right? We can have sodium sulfate, right? So, and when it is partial, then it can be sodium hydrogen sulfate, hydrogen carbonate. So that is partial. Now, a reaction in which hydrogen of alkane is replaced by halogen. Now here what is happening? Replacing. So replacing can only take place when there is a substitution reaction. So alkane, suppose we take C2H6, it combines with halogen, say chlorine. So you will get C2H5Cl, right, plus HCl. So here there is substitution reaction. Next we come to D. The energy required to remove an electron from the neutral gaseous atom. Now neutral gaseous atom, when you remove electron, right, then ion is formed in the reaction. The energy is known as ionization energy or ionization potential. Okay, and when electron is added, it is electron affinity. Okay, then we talk about E part, the homogeneous mixture of two or more metals. Now whenever it is a homogeneous mixture of metals, right, mostly there are metals, rarely you get non-metals in between, and in their definite proportion, then it is what? It is an alloy. So this is the definition of alloy. So all the 4 points clear, right? Next we come to the fill in the blank. Right now, fill in the blank, options are given, you have to select. So when sulfuric acid reacts with zinc, so H2SO4 reacts with zinc, so the gas evolved. So what will happen? Zinc will combine with sulfate, right, and you will get what? Hydrogen. So the gas evolved as hydrogen. Okay, now it can be tested by burning splinter. Yes, it is going to burn with pop sound blue color. Okay, then a solution of copper 2 sulfate and sodium hydroxide solution. So copper sulfate will combine with sodium hydroxide. It is going to form copper hydroxide, which is blue in color. Sodium sulfate, right, we balance this. So it is what? It is pale blue color. And what happens when you add excess of ammonium hydroxide, not sodium hydroxide, the reaction remains same. But if you add excess of sodium hydroxide in place of sodium hydroxide, then this pale blue changes to deep inky blue solution, right? Now we come to C part. In methane, each hydrogen atom shares. Okay, so this is carbon, electron dot structure, right, carbon, and you have got hydrogen. Okay, now what is happening? Methane is going to share, right? So this is one hydrogen has one electron and is going to take another electron from carbon. So likewise, all the 4 hydrogens will take one electron each from carbon, and carbon is going to take one electron each from hydrogen to complete its octet, right? So in methane, each hydrogen atom shares one electron with central atom, right, to complete its valence chain. Then electron affinity of element X is greater than that of element Y. Okay, now you have to understand that what is it, what is the trend. So when you move left to right, electron affinity increases, top to bottom decreases. When it is increasing, that means it is not, now it is increasing, that means it is not going to give electron, it will have tendency to accept electrons. Okay, now it says X is greater than Y. So that means if if X is greater, that means here you have got X and the position of element is here Y. Then only X will have a greater electron affinity as they are moving left to right. Okay, now it says the oxidizing power. Now oxidizing power will be more, okay, will be more than that, because what will happen, it will have the tendency to accept, the electron, right? So its oxidizing power will be more. Now we come to fifth part, the naturally occurring compound of a metal, right, is always, right, and from which the metal is extracted. Now when it is naturally occurring compound of a metal, it is always known as mineral, but when we extract from that mineral, then it is ore. So the answer is ore, right? Is this clear? Now we move on to the fourth part of second question. So you have got column A, you have got column B, and you have to match the column C. Children, you are not going to copy, right? But remember, you have to see this is A, B, C, D, E. So remember that you mention the correct option given in the column B. Okay, so we talk about aluminium. Over here, the best suit is Hall-Herold's process. In the extraction of aluminium, in the purification part, we go for Hall-Herold's process. Then when we talk about sulfuric acid, this is contact process, because you manufacture sulfuric acid by contact process. Then calcination is actually heating the ore in the absence of oxygen, okay, or limited amount of oxygen, and this is generally conducted for which ores? For carbonate ores. Then we talk about calcium chloride. Now calcium chloride is CaCl2, which is formed by an electrovalent this by transferring of electrons. So calcium has got two electrons, these two electrons are given one each to chloride. So calcium gets positive charge, chloride gets a negative charge. So this is an electrovalent compound. When we talk about carbon tetrachloride, CCl4, so here carbon equally shares with 4 chloride, hence it is a covalent compound, right? So this is how you are going to match. So the answer will be, if it is A, then A it is 3, right? Then for B it is contact process 4. So this is how you're going to write. C it is 2, okay, then D it is 5, and then E it is 1. So this is how you mention. Otherwise you can write same in front of, but this saves your time. But while writing you have to be cautious, don't make mistakes, okay. Then we come to the interesting, so you have to write IUPAC names. So okay, tell me, what is the full form of IUPAC or IUPAC? We call generally this as IUPAC. So it is International Union of Pure and Applied Chemistry. We follow this for having the universal name throughout for organic compounds, okay. So if you see over here, there are 3 carbon, right? So 3 carbon means prop, right? All the bonds are single, that means there is no double, triple, that means there is ane, and here you have OH. So that means this is propanol, right? And this OH is on which position? you have to count from the side where you give minimum number to the functional group. So OH is the functional group. You count from here, you give one number, and if you count from here, then it will be 3. So this side is wrong. You'll count from right hand side, and the name will be propanol, right? Propanol 1. You can write 1 propanol, or you can write propane 1 all. So these are the 3 styles in which you can write, but would prefer this one. Next, second, it is 1 2 3 4 5. So how many carbons are there? 5 carbons are there, and on first you have a double bond. So 5 carbon pent, 5 carbon is pent. There is a double bond, so it is ene, and the position is 1. So you can have again 1 pentene, or pent 1 ene, or pent ene 1. So you can go for this one. There are 3 possibilities to write the name. Okay, next let's draw the structure diagram for but2ine. I'm erasing this, otherwise there will be less space to write. Answers are already there in the specimen paper. The idea of over here in this video is to explain, to make you understand. Your concept should be clear. Okay, so draw the structure. Now it says but. So but means 1 2 3 4. Now it says on second there is ine. So if I count from here 1 2, on second there is ine. Ine means 3. So this is what. Now rest you will have, all the carbon should have 4 hands. So 1 2 3, 1 2 3 4, 1 2 3 4, 1 2 3. So here you will have hydrogens. Okay, so this is the structural diagram for but2ine. Then 1 1 1 trichlorometh. Meth means 1, methane means 1 carbon with 4 hands, and on all these you have got chlorine. 1 1 1 chlorine. So here you have hydrogen. So this is the structure of, otherwise what do you call, the common name is chloroform. Okay, so 1 1 1 trichloromethane. Now last structure, pentane 2 all. Pentane. So 1 2 3 4 5. All means there is OH group. Okay, and where it is there, it is there on second carbon. Okay, so 1 2. So on this carbon I put OH, and on rest all carbon should have, remember, 4 hands. So 1 2 3 4. For this carbon, hydrogen hydrogen hydrogen. So just a second, this it got shifted. Okay, so it is not clean. I will write this again. This is the issue when you use the pen, right, on the PDX editor. So 1 2 3 4 5. On second you have OH, on rest other you have hydrogen. Okay, so put hydrogen. Right, now children, remember where you lose marks. You lose marks when you are writing the bond. So it has to be COH. Generally what children do, they write C, they write H here and O here. No, it has to be C and O, carbon with oxygen. This should be very clear. Okay, right? So when you are drawing the structure, you have to make sure that you are showing proper covalent bond. Okay, right? So thank you, happy learning. In my next video you are going to find question number 3 solved. Right? Thank you.